So now we want to look at some of the reasons why reliability programs fail. Why reliability programs fail. Now, if you look to the right of your screen, you will see that plant reliability is actually dependent on three variables, so to say, or three parameters. One is the asset itself. Let me put it like that, because this one, the people, they are also assets to the facility, but the equipment, okay, or the plant facility itself. Then the other factor that affects the plant reliability is the process. And the third, they are those that will operate the process, okay, that will monitor they operate the equipment, go operate the process to give our deliverables at the end of the day. So you will see that statistics, research have actually shown that the people factor in this combination actually contributes about 38% of the reliability issues or problems that we have in our facility. That's quite enormous. While the process, that is the steps you take during operations, okay, or even the process or procedures that you undertake during maintenance, all of those contribute to 34% of the unreliability that we have in most plants. Are we getting it? That is reliability issues or problems that we have in most of our facilities. While the equipment itself contributes just about 28%. Surprise, right? But that's the fact. And one of the reasons why most reliability programs fail is that our reliability improvement strategies, they are usually concentrated more on this equipment. And as you can see, they can only contribute about 28% to the success of your reliability program if you ignore the other factors. Are we getting it? So if in all ramification you agree with me that 28% is gross failure, so if you leave these two, okay, the people and the process or procedure, that means you have already set your process for failure. So as we'll see later, we'll see how all of these always affects our reliability program. So the integrated reliability program always looks at these three variables and see how they can make each of them to be more reliable. Okay, now, like we said earlier, most times when we deploy reliability program, we just look at the equipment. Let's take, for example, a facility may decide to want to improve the reliability of, let me say, the pump system, okay? That is the pump and the driver that is attached to the pump. And that facility may decide to say, okay, we want to improve reliability, let's go for vibration monitoring and analysis. Now, when you go for vibration monitoring and analysis, or even oil analysis, you see that your concentration is on the equipment. Okay, vibration will help you to look at the condition of the equipment. Vibration analysis. So that condition of the equipment can only tell you when the equipment actually needs to be maintained, as we will see later. Now, even on that vibration monitoring, most facilities, they are ignoring the process of monitoring the equipment vibration. So that is the reason why you see that when technician A goes to monitor, take the vibration on a particular asset, and technician B goes to take the vibration reading of a particular asset or go to analyze, you see that the probability of both of them having different interpretation and results, they are always there. Okay, or we may say, okay, the equipment is failing so frequently, we assume, or maybe we carried out root cause analysis and discover that maybe the problem is from misalignment of both couplings. We decide to deploy laser alignment technology during installation, after maintenance, and what have you. So when you deploy this laser alignment technology and what have you, the process of installing back those components of the facility, they are always ignored. And as we all know, that process contributes to a large extent to some of the problems that we will later see during operations. Those misalignment problems, vibration problems, and what have you. That process, okay? And that is the reason why you see that since technician A or crew A we adopt maybe their own process that is different from what crew B will do. That's why you see that most facilities say, if this person is not around, please don't go and couple that pump. Are we getting it? It's as if he's the only one getting the process right. So if the process is in place, clearly planned and articulated, you see that A and B will tend to achieve the same result. As we all know, the process determines the result. So focusing on the equipment alone will not give you the desired reliability. The reliability of those that will be carrying out that process, that installation, how skilled are they, how knowledgeable are they about that particular process that they are getting themselves involved in. Okay, so the process, is it a defined process? Do we have on each of those are maintenance procedures, operations procedures, and what have you? Do we have a standard operating procedures on each of them so that when technician A comes, he will follow the same procedure in installing that particular equipment or operating that particular process, okay, so that the result at the end of the day will be the same. Let's take, for example, maybe we want to couple a flange, okay, flange of a two, either pipeline or the pipe to the discharge or inlet to your pump. Are we getting it? You will see that if technician A that is having more strength comes to do that installation, the tendency of him torquing those bolts, okay, close to or even more than the actual torque is there than technician B that have less strength to actually torque those bolts to the. So do we have a standard torquing procedure? Okay, remember those bolts, there is a pattern you need to adopt in tightening them. Do we always follow that pattern? Remember, each of those bolts, they have a torque level that they can actually sustain so that you do not strain the bolt at the end of the day, okay, and makes it to lose its integrity. So if technician A goes there and decides to use his own understanding or mind in determining the right torque level, the tendency, if he has that strength, of him over-torquing that bolt, since he has nothing to measure the torque, over-torquing that bolt, straining that bolt, and at the end of the day, you have loose joints that will result to leak at that joint, or that may result to misalignment. And even over-torquing can strain the gasket between such joints, thereby reducing the integrity of that particular joint. What about if we have a standard process in place in making that joint? Okay, a standard material definition that tells us the actual gaskets to use, the size of bolts to use. Then we have the appropriate torque wrench, okay, be it hydraulic or manual, whichever, that is appropriate for the making of that joint. Do we have it in place? Are we getting it? So if they are in place, you see that if technician A or crew A comes and follow the SOP, the standard operating procedure, and technician B or crew B comes and follow the same SOP, definitely the results will be the same. Okay, so you see that for your reliability program to be successful, you need all three to be reliable. You have to integrate the reliability of all three. That is, those that will be manning the process, their reliability must be ensured. The process reliability also must be ensured, and the equipment itself, reliability of the equipment must be ensured. If you are also looking at the reliability of electrical systems, they are the same thing. The same thing. Let's take, for example, now the maintenance of an electric motor or an alternator, for example. Okay, let me say an electric motor. Maybe the normal PM for your bearing on that electric motor, say after 5 years, because of the stress that that bearing is facing, do change out. Even if the decision to change out that bearing is condition based, what are the procedures that needs to be followed in changing out that particular bearing? Then if we move into the windings, what are the procedures? Maybe we have problems with the windings. What are the procedures we need to follow in testing and determining whether we have issues with the problem? Not only having the equipment to test, those that will be using the equipment must be knowledgeable on what they are looking at, the test process, and what they should be expecting at the end of the day. Then if they are able to come out with sound results, of course, once the process is standard, if A goes there to do the test and B goes there to do the test, the likelihood of both of them having the same test results is high. Okay, so if the result says winding failure, winding change out, what are the procedures that you need to follow to do that winding change out to ensure the integrity of the entire asset when it is returned back to service. Are we getting it? So you want to ensure the reliability of as you are trying to ensure the reliability of the equipment, you also want to ensure the reliability of the process and those that will be manning the process. So as you see, we really need all three to realize the true reliability potential of our assets. Okay, so these are some of the reasons why reliability programs fail. In summary, you see that most of the times we may concentrate on the equipment. Are we getting it? At times, some facilities, they will feel that buying a reliability program, that is software, computer program, will ensure reliability in their system. They will end up giving the maintenance personnel or their personnel additional work that they don't see the need for in their system. Okay, which means additional stress in trying to incorporate or determine the usefulness of such a buy to their system. Reliability programs are good. Okay, that is the computer programs. They are good because they will help you to generate enough data for you to understand your asset or your process. So how do you integrate those data that you have acquired now into your operations? That becomes another task. Are we getting it? So that program alone cannot guarantee reliability. Then when you go and buy equipment, maybe infrared camera, vibration analyzer, laser alignment toolkits, lube oil test kits. Are we getting it? You go and buy such equipment, you will see that you are only looking at those the asset, that is the equipment itself. Okay, you want to ensure their integrity, forgetting that in integrating those equipment or instruments into your system, the people and the process, the people have to be carried along, trained in using those systems and then integrating it into your process. So those are some of the challenges. And then at times you see that after acquiring that process, which is a known fact, instead of those equipment, instead of them helping you to improve the reliability of your facility, it will be giving you more problems. Instead of reducing your maintenance costs, it will be increasing your maintenance costs. Are we getting it? Because the time that you introduce such components in your facility, maybe as we'll see later, your equipment is already entering the wear out region. Okay, so the probability of getting problems with them will be high. And then if the process is not well defined, the handler, those that are operating the process, they are not knowledgeable enough. What they will be seeing is problem. We had an experience with a client who deployed the infrared thermography on their system. So we just a few short training, 3-5 days training, they fed their technician, they are good to go. So this technician, each time they go to visit their facility, a particular pump always have the thermogram of that particular motor driving that pump is always showing as if we have a lot of hot spots on that particular motor. So you see that once they see it, see it like hotspot, they just flag it that the motor needs repair. Okay, so each time they go to the facility, that motor they always flag it, and each time they do that, the facility spends a lot of money replacing that motor. Not until one day the plant manager decided to stop the condition monitoring guys from coming with their camera, and they discovered that when the condition monitoring guys were not coming with their camera, they were able to use that motor for years without issues. What was the problem? Those technicians, they actually don't appreciate the condition under which that motor is operating. That is its normal operating thermogram, and that is what they fail to realize. And that is the danger, okay, of not integrating your reliability system. So trying to improve the reliability of just one of the components of this, as we can see on the screen, will not make your system reliable. We need all three. We need the people, the reliability of the people, that of the process, and that of the equipment for us to gain our reliability properly. So the critical success factors: one, we need people. There is necessary technology, okay, that will help us to look into the assets without opening up the asset, especially, okay, such technology. And then the process also, as we said earlier, we need to create a standard process, a reliable process. And of course, we need data, okay? And these data, they can come from all of the other reliability suits that needs to be put in place to make sure that our system is, our asset is reliable. We mean your CMMS system, your condition monitoring systems, your everything, okay, that we extract live data from the assets to help you appreciate the operational status of the data and know precisely what to do at the right time.